Alright everyone, I'm going to be doing some of the 9.1 problems right here, just in case you need some help. I'm going to be using these equations, and I already kind of went over this in class. So, here we go. I have mass times specific heat times delta T. So I'm always going to be starting with this equation. Q is equal to M times CS times delta T. Now I just plug in what I know. I have my mass is equal to 500 grams. Ooh, that period at the end means that I have three significant figures. My CP is the same as the CS in these ones, so 4.184. And then my temperature, remember, that's always going to be final minus initial. So my final comes after the word 2 is 35. 35 minus my initial is 25. So that's going to be 500 times 4.184 times 35 minus 25, which is 10. So if I do my calculator, 500 times 4.184 times 10, and I get 20920, and my units is in joules. If I want to convert this to kilojoules, I would divide this by 3, so I have 20.92 kilojoules, if you want to do it that way. Alright, let's look at this one. Same equation. Q is equal to M times CS times delta T. I have 150 grams times specific heat is 0.44, and now I have 100 minus, it cools from this to this, so it's 100 minus, look how wicked hot it starts. That's roughly half the temperature of my mixtape, roughly. 100 minus 525, and I get negative 425 times 0.44 times 150, and oh my goodness, it's quite a bit. It's minus 28050 joules. One thing that you should notice here is this is a negative number because it is released, while this is a positive number because it is absorbed. Alright, if I want to turn that into kilojoules, divide by 1,000, I have 28.05 kilojoules. 3 sig figs, ooh, this should just be 20.9. How many sig figs here? Only 2, so it should probably just go from, actually 3 there, 3 there, 3 there. So we're just going to go to 28.1. Sounds good? Sounds good. One more. I'll actually go to something on the back because these are a little bit harder. In this case, a metal is going to be releasing some energy and the water is going to be picking it up. So what we do is we say M times CS times delta T of the water is going to be equal to negative M times CS times delta T of the metal. Does that make sense? That makes sense. So let's look at the water first. Okay, the water, this gives me the mass of the water. Oh, look at that, 100 grams of water. So 100 grams of water. The CS of water is 4.184, 4.184, and the delta T of the water is the final temperature is 45.5. The initial temperature is 25. So that's my water. Now with my metal over here, I have 72 grams. Alright, also have a negative sign. My CS is, I don't know, I'm doing that. My delta T is, it started at 97, so it's my initial, but check this out. My final is also going to be the final temperature of the water. The final temperature of the water and the final temperature of the metal are equal, so it's 45.5 minus that. So I can do some math over here. 45.5 minus 25 is equal to 20.5 times 4.184 times 100. So on this side of the equation, I have 8577.2 is equal to, let's do this, 45.5 minus 97, and I have minus 72 times this part right here, which is negative 51.5 times the CS. This negative times the negative will make a positive, so now 72 times 51.5, and I get 3708 times the specific heat is going to be equal to 8577.2. I divide both by 3708, divide by 3708, and my specific heat in this case, I got something to be, the specific heat to be 31. 2.3 with sig figs. And the units for that is joules per gram degree Celsius. Cool? Cool.